All right, let's take a look at this particular example. Okay, so similarly, let me just give my current to the same manner as I have always been doing it. It doesn't matter the way you decide to give your current, the direction, okay? It will always come back to the same solution. All right. So here, so as usual, we are moving from the negative to the positive. So our voltage is increasing from the negative to the positive, from our direction, the direction of our loop, from the direction of our loop. Okay, so this is what? Loop 1, from the direction of our loop. Okay, so here is positive 140. All right, and then we're going to have here will be positive, negative, because our loop is going this way. Wherever it passes first, that place will be positive, and wherever it's leaving, it will be negative. So it's passing here first, so positive, and it's leaving the resistor at this point, so negative. It's in this resistor, it's passing here first, positive. It's leaving at this point, negative. Okay, so here you see that it is passing from the positive to the negative, so there's a voltage drop, or because the direction of the loop is the same as the direction of the current, so that signifies voltage drop. Okay, or because it's from the positive to the negative, which means it is decreasing, so voltage drop. And here also from positive to negative, it is decreasing, so voltage drop. Or because the direction of the loop is the same as the direction of the current, that means what? Voltage drop. So minus 20 I1 minus 6 I2. Okay, then let's come to this place, loop 2. So here I'm starting from here, so here is what? Negative. I'm going to positive, that means voltage is increasing. Okay, so 6 what? I what? 2, positive 6 I2. But so here it will be this way. Okay, here it will be like this. Okay, so here, because the loop is going this way, so here will be positive, here is negative. Okay, so now because the loop is going the same direction as the current, okay, it signifies a voltage drop, or because it's from positive to negative, which means it's not decreasing, positive to negative, so it's what? Voltage drop. So minus 5 I3. Okay, so here from positive to negative, it means it's what? Positive to negative means it's what? Decreasing. So minus 90 is equals to what? 0. So here it must be equals to what? 0, because the voltage in the loop. Here is equation 3, equation 2, and equation 1. Alright, so now let's solve these 3 equations. Okay, so let's just solve these equations. So let's say equation 1 into 2 as usual. Okay, it doesn't matter the way you decide to solve it. Okay, your answer will come out to be the same. So 140 minus 20 I2 plus I3 minus 6 I2. So 140 minus 20 I2 minus 20 I3 minus 6 I2. Okay, so here I'm going to have 140 minus 26 I2 minus 20 I3 is equals to 0. Okay, is equals to 0, is equals to 0. Okay, so 140 minus 26 I2 over 20 is equals to what? I3. Okay, so this is equation 4. Okay, so let's see 4 into 3. So 6 I2 minus 5, 140 minus 26 I2 over 20 minus 90 is equals to 0. So if I should multiply here by 20, then I'm going to have 120 I2 minus so we will have 250 I2 is equals to, we have I2 to be 10 amps. So now I2 into equation 3, no, I2 into equation 4. So here we will have 140 minus 26 into 10 over 20 is equals to I3. So 140 minus 260 over 20 is equals to I3. 260 over 20 is equals to I3. And so now let's say I2 and I3 into equation 1. So I1 is equals to 10 minus 6, which is equals to 4 amps. So that means I1 is equals to 4 amps. Okay. So these are the solutions that we have. All right. Let us see if they are going to work for our circuit. So this is a circuit that you are dealing with. Here is 140 volts. Okay, that is 140 volts. Okay, so this place was I1, and here is 20 ohms. Here is 5 ohms. Here is 6 ohms. Here is 90 volts. So that is all. Here was I2, and this is I3. Okay. So now let's find the various voltage drops across resistors. Okay, so the 20 ohm resistor, what's the voltage drop? So it's going to be 20 times I1, and I1 was 4 amps. So we're going to have 80 volts. So I'll have 80 volts here. So if you subtract 80 volts from this 140 volts, I'm going to get 60 volts here at this point. I'll get 60 volts at this point. Alright, that means at this point I'll get 60 volts. What's the voltage drop in this 6 ohm? Okay, so this 6 ohm, the voltage drop there will be 6 times I2. I2 was 10 amps, so times 10 amps, which is equals to what? 60 what? Volts. So the voltage drop here is 60 volts. So if you subtract this 60 volt from this 60 volt, that means here is what? 0 volts. If here is 0 volts, here there is no voltage drop. That means here is also 0 volts. That means it is correct for our loop 1. Okay, it's correct for our loop 1. Now, because the sum of the voltage in the loop must be 0 volt, and we got it to be 0 volt. And this 5 ohm resistor, so that one we're going to have 5 times I3, and I3 is minus 6, so minus 6 amps. okay, minus 6 amps. So 5 times minus 6 is going to be 30. Okay, it's going to be negative what? 30 volts. Okay, it's going to be negative 30 volts. So that means that the voltage drop here is negative what? 30 volts. Okay, so now 60. So now we're going to have 60 volts minus what? 30 volts, which is what? 90 volts. So I'll have what? 90 volts here. So if you subtract, here is what? Positive. It's going to negative. That means that it's decreasing, it's negative. So 90 minus 90 here will be what? 0 volts. So here is 0 volts. That means that there's no voltage drop here. Here will be 0 volts. There's no voltage drop here. Here also was 0 volts. That means that our circuit is what? Correct. Okay, so that means that our answers are very correct. Thank you so much for listening to these lectures. All right, enjoy your time. Bye bye.